So for this question, question 23 says that a motor company has purchased steel parts from a supplier for several years and has found out that 10% of the parts returned must be returned because they are defective. Okay, and it says that an order of 5 parts is received. So, what is the probability that not more than 3 of these parts are defective? Okay, so if you have a problem like this, it is actually a problem that is associated with the binomial distribution. Okay, so it's binomial distribution. And how do I know it's a binomial distribution? Because we have two possibilities. It's either we have parts that are defective or parts that are not defective. So here, in this case, if we receive a part that is defective, then it will be a success. So it will be our success. So with binomial distribution, we have two options. We have two probabilities. We have a probability of success or a probability of no success. So here, probability of success is defective. Okay, so we have a probability of 0.1. Okay, we have a probability of 0.1, and we have n, which is equals to 5. This is the number of passaries that are received. We say that we have n being equals to 5, and then it says what is the probability that not more than 3 of these parts are defective. Okay, so we want to know the probability that not more than, so it must be less or equals to 3. Okay, so it must be less or equals to 3. So you can use binomial tables to actually get your answer. Okay, I don't think I have my tables here. Okay, so you can use the binomial tables. So if you don't know how to use binomial tables, you can tell me and I'll show you. So you will find out that the answer is actually close to 1. So it shows this. Okay, and then question 24 says, what are the mean and the standard deviation of defective parts? Defective parts, what are the mean and the standard deviation? So with binomial, we can approximate a binomial. We can approximate a normal distribution by a binomial distribution. Okay, and then we can say that the mean is equals to what? Is equals to the mean of a. This can be approximated by a normal distribution. Okay, so the mean will be what? Will be NP, and then the standard deviation will be the square root of NPQ, right? If I'm not mistaken. So we found out that if we can say NP, then it's 5P is 0.1. What we have is 5 times 0.1, which will be the mean equals to 0.5. And then the standard deviation will be the square root of 5 times is the square root of 5 times 0.10 times 0.9. Q is 1 minus P, right? When we have 0.67. So it means that this is the correct answer. Number 3 for question 24. Okay. So here it says that tornadoes for January in Kansas average 3.2 per month. So the probability that in the next January, Kansas will experience exactly 2 tornadoes is, okay, so here we have a Poisson distribution. So why do I say we have a Poisson distribution? It's because we are talking about per month. We're talking about a certain interval. We're talking about a certain time interval. So when you read a question that has to do with a certain time interval, then you know it's probably going to be a Poisson distribution. So here they said the tornado for January in Kansas averaged 3.2 per month. So you know that it's a Poisson distribution. So what you are going to do is you are going to calculate the probability that the next January Kansas will experience exactly 2 tornadoes, the probability that X will be equals to 2, and then according to a formula for the Poisson distribution, you're going to have E to the minus lambda x to the power of lambda to the power of x factorial, right? Where x can be from 0, 1, 2, and so forth, right? So you're going to substitute E to the minus lambda. Lambda here is your mean, which is your average, which is 3.2, which is 3.2 per month. And then you have 3.2 to the power of x. So x here is equals to 2, and then over 2 factorial. Okay, so you punch this answer on a calculator, and then you find out that the answer is equals to 0.2087. Okay, so this is our answer that we got. Okay, so we move on to the next question. So question 27, it says that for a set of data, the mean is 50 and the standard deviation is 10. So in raw data, one observation is equals to 74. After data is standardized, what will the standardized value be? So I said the standardized value will be equals to what? 2.4. Okay, so here I made a formula. This is the formula. Here, this is a formula for transforming raw score to z-score. So basically, you're going to say x minus mu, which is your mean over the standard deviation. So if you punch that, where x in this case will be 74 minus 50 over 10, you will get this 2.5. Okay. Okay.